Action.
Just last week, my 4-year-old sister dressed up as Wonder Woman and was so ecstatic to go trick-or-treating. She came back with a huge bag of candy and couldn't have a bigger smile on her face. But not everyone was as lucky as her. One of her friends, Anna, couldn't go because she's diagnosed with type 1 diabetes. It was difficult to explain to my sister why her friend couldn't eat candy. Now, imagine a world where Anna could be cured by replacing her diabetic pancreas with a new one, grown from her own tissue. This is the promise of the field of tissue engineering, a reality where the solution to your health problem is realized by engineering your own cells into a specialized tissue that is the perfect fit. We at Vivodish are here to do just that, using Penn's intellectual properties. We're here to offer a novel cell culture dish that will speed up this research discovery process and tap into the $40 billion tissue engineering market by revolutionizing the $500 million dish culture market in the US. The most widely used cell culture products today, used for out-of-body or in vitro research, are just flat plastic or glass surfaces that do not mimic the original real-life environment that they came from. For cells to grow in a more organized and realistic way that's necessary for tissue formation, they need to feel like they're at home, and not on some flat, featureless surface. Since home to the cell means texture on the nano and micro scale, surface wrinkles can simulate just that. Studies have shown that cells do respond to nanostructures, and when grown on these wrinkled surfaces, they align and grow more similar to their in-the-body counterpart. Research also shows that making these wrinkles takes too much time. One current method uses small stamps, which is cumbersome and time-consuming. One dish can cost over $150. In the world of research, where hundreds of cell culture dishes are used and thrown away, it's easy to see why this hasn't been adopted overnight. Using Penn's groundbreaking tech, we have an answer. Using the high throughput capability promised by the roll-to-roll surface wrinkle printing, we can finally provide smarter cell culture surfaces that mimic real in vivo environments in a cost-effective and sustainable scale. What's great about the roll-to-roll printing method is that we can easily vary the size, width, and pattern of the surface texture on our culture plates, catering to the individual needs of different customers at virtually no cost difference. Our short-term goals revolve around getting both proof of concept and a viable prototype. The skills here include research and development capabilities. Here, we're hoping to partner with the Penn Tissue Engineering Labs, and we've already reached out to Professor Dan He, who's given us some initial support and guidance on this matter. In the medium term, we'd like to sell to 5 large academic organizations that are in the nearby Pennsylvania area. To do this, we would need supply chain and product delivery capabilities. In the longer term, we'd want to scale production and provide customer solutions. This means developing new product lines and customizing the size of nanowrinkles based on our customer segment needs. This also means that we'd want to manage the distribution of Vivodish to newer customers, potentially worldwide. Our approach is to develop a proof of concept over the next 6 months of funding. Within a year, we plan to have a working prototype to secure contract commitments from 5 large research institutions, which will then deliver over the next several years. By the 5-year mark, we plan to have developed production at scale and fine-tuned custom Vivodishes as our next product offering. Among our founding team, Susie brings 3.5 years of finance experience to the table. Claire has spent time developing industry knowledge and a network of contacts through her healthcare tech and food and beverage experience. I myself bring engineering expertise in the chemical and biomolecular fields through both my studies and working in various research labs. As a nursing student, George has built up a strong network in academic research institutions through his role in student government and involvement in the UPenn hospital system. We understand that there are still several gaps within our team, specifically tissue engineering expertise, supply chain and manufacturing knowledge, and legal. Less crucially, we'd also like to add team members focused on operations and marketing as we validate our prototypes and scale Vivodish. Join us as we disrupt the multi-billion-dollar tissue engineering industry through our application of nanowrinkle technology.